Okay, so in this unit we've learned a lot of different facts about different segments, different types of lines dealing with circles, and so this is just going to be kind of like a cheat sheet really to just give you all the different rules and stuff that we've learned, or most of them anyways, from this unit. Okay, and so this is not necessarily going to be in the order of what we learned it through the units, just kind of basically is how I just put it on here. So, all right. On these first ones, what I'm going to talk about is like the length of the segments. So what I'm going to do is we're going to say if this piece from here to here is A, and this piece from here to here is B, and then we'll say from here to here is C, and then from here to here is D. Okay, so what we know in this situation is that if you take segment A and you multiply that times segment B, that equals segment C times segment D. So this times this equals this piece times this piece. So that's the generic rule for what happens in this situation. Okay, next one, we're going to say from here to here is A, from here to here is B, from here to here is C, and then from here to here is D. Okay, so if you remember on this one, this is what we learned, like the last thing that we learned. So the whole thing here times the outside equals the whole times the outside. So I'm going to write this in two different ways. So I'm going to write like this. The whole times the outside equals the whole times the outside. Okay, or the other way to write that with the letters that we have on here representing the lengths is the whole thing of the top one up here, okay, is going to be A plus B times the outside piece, which is A, okay, and then the whole thing down here on this one, the whole thing would be C plus D times the outside piece, which is C. And so that is going to be, again, the general idea of what happens with that. Okay, on this one, we learned this one a little bit earlier in the unit, but just remember, if this piece right here is a tangent piece to the circle, you know, from this point, tangent here, and if this is a tangent from that same point to right here, remember what's true is that these two are congruent to each other. Okay, so I don't know how to put that, but anyways, just remember that these two, let's do it like this. Okay, just remember that those two pieces are congruent to each other. Same length. Okay, on this one, this is where we have a tangent and a secant, where they meet on the exterior of the circle. So what I'm going to do is I'm going to say from here to here is A, I'm going to say from here to here is B, and then from here to here is C. And so I'm going to write this in two different ways also. So on this one, it's the whole times the outside equals the tangent piece squared. Okay, so the whole, okay, this whole times outside is talking about this piece. Obviously, the tangent is talking about the tangent piece. So the whole thing is going to be B plus C. Okay, and remember that I just kind of breezed through that, but remember, this whole thing is B plus C. It's very tempting to want to do B times C, but it's not. It's just adding them up. B plus C gives you the length of the whole thing, so remember that. Times the outside piece, which is B, equal to the tangent piece, which in this case is A squared. So B plus C times B equals A squared here. All right, let's talk about angles for a second here. So remember on this one, this is what we call a central angle for very good reason. It's an angle that's, you know, the vertex of the angle is the center of the circle. So remember on a central angle, if the central angle is 90, then this minor arc that it creates is going to be 90 degrees also. So just remember the central angle and the arc it creates are congruent to each other. All right, this next one, remember, this is not a central angle. This is what we call an inscribed angle. And remember, the inscribed angle is half of its intercepted arc, or the arc that it creates. So I measured this on paper a little while ago, and this angle is about 35 degrees. So if that angle is 35 degrees, then this arc out here is going to be double that, is going to be 70. So remember, the angle, the inscribed angle is half of the arc, or you could think of it as the arc is just double of what the inscribed angle is. All right, on the back. Okay, so talking more about angles here. So on this one, what I'm doing is I'm looking for this angle right here. Okay, so if we know this arc, let's say this arc is x degrees, and if we know this arc right here, this little piece, say this arc is y degrees. So on this one, it is x minus y divided by 2 gives you the measurement of that angle. Okay, you have these two secants that are intersecting on the exterior of the circle. So remember, whenever it's on the exterior, you're going to subtract here. It's x minus y divided by 2 gives you the measurement of that angle. Okay, here we have them intersecting in the interior of the circle. Okay, so like let's say we have this arc here. Let's just say that's x. And let's say we have this arc here, that's y, and let's say I'm looking for this angle right here. So remember, on this, what you're going to do is you're going to take x plus y divided by 2, and that gives you the measurement of that angle. And of course, these two angles are vertical angles, so they're congruent. These two angles right here, this angle and this angle, are a linear pair, they're supplementary. Okay, on the next one, we're going to be talking about this angle right here. Okay, and so that angle from this tangent and the secant creates this arc out here. Okay, and so two ways to think about that. You could think about it like this: the arc divided by 2 gives you that angle, or the angle times 2 gives you the arc. It's basically, well, it is the same thing as like an inscribed angle. The arc is going to be double whatever this angle is, or the angle is half of the arc. Okay, and then one other thing that we learned very early on in this unit is looking for the actual length of this arc right here. So if we're looking for the arc length, so it's like the actual, if we were to measure how long this is from here to here. So what we're going to do is we're going to have the measurement of this angle, and we're going to have the radius of the circle. And the way we find the measurement of that arc length is we do 2 pi r times m over 360. And that's right there, because remember, 2 pi r is the way you find circumference of the entire circle. So 2 pi r gives us circumference of the whole circle. This m over 360 is where we scale this down to find this, because 360 total degrees, this m over 360, this necessarily is going to be less than 1. So it's what scales this down to find the actual length of that arc instead of the circumference of the whole circle. Okay, and so on this one right here, all right, so the circumference of the whole circle, remember, two ways you can find circumference. Circumference equals pi times diameter, or circumference equals 2 pi r. Alrighty, and then I just have that extra circle there. I'm not going to use it for anything.